Hello everyone, this is Mr. Tanner, and today we're going to be going through our notes on the layers of the Earth. And we're going to be looking at both the compositional layers, or the layers that are based on the materials that the rocks are made of, and the mechanical layers, which is the properties or the behaviors of each of those layers. So let's go ahead and get started. All right, looking at those compositional and mechanical layers, there are three compositional layers. And again, these are the layers of the Earth that are sorted by the materials that they're made out of. So this is looking at which layers of the Earth are made of different types of rocks or sometimes metals. So they have different elements and molecules in each layer. Those three compositional layers is the crust. That's the outermost layer. It's very, very thin. It's rigid and brittle. It's largely made of like granites, andesites, basalts. These are the rocks that we encounter on the surface of the Earth. The second layer is the mantle. That's the second compositional layer. It's made mostly of peridotite. It's a more dense rock. And then we have the core. And compositionally, it's a single unit because the entire core is made of iron and nickels and other sulfur-rich metals. So again, the three compositional layers, the crust, the mantle, and the core. Crust, mantle, core. There is also 5 mechanical layers. Mechanical layers are sorted by the, and I kind of put this in quotes, the behaviors of those layers. They obviously don't have behavior, they're not alive, but they react in different way, especially to stress. So when something is pressing on them or there's pressure from the layers above, they react differently. So, for example, is the layer brittle, or does it flow? Is it liquid or solid? Is it hard or soft? These are all different, quote, behaviors or properties of the layers. There is 5 different mechanical layers. Going from outermost to innermost, we have the lithosphere, the asthenosphere, the mesosphere, the outer core, and the inner core. So those are the compositional and mechanical layers, and as we go forward, we're going to learn more about each of those layers. These notes are organized going from the outside of the Earth down towards the middle of the Earth, and the outermost layer is the crust. The crust is a compositional layer. We're looking at what it's made out of, and the crust is the outermost layer of the Earth. It's largely made of basalt and granite. And there's 2 different types of crust. There is oceanic crust. That's the crust that's underneath the oceans, and it's mostly made of basalt. You don't have to write that into your notes, but it's mostly basalt. And then there is also continental crust, and it's mostly made of granite. There's obviously lots of other types of rocks, but we just look at these as giant categories here. Of those 2 types of crust, oceanic crust is thinner than continental crust, and it's also more dense. So it's thinner, but it's more dense. Continental crust is thicker and less dense than oceanic crust. And that's really important to remember. Oceanic crust is more dense than continental crust. Going down, our next compositional layer is the mantle. And again, it's compositional because the mantle as a whole is made mostly of peridotite. The mantle lies directly beneath the crust. And if you separate the outer core and inner core into their 2 separate layers, the mantle becomes the thickest layer of the Earth as well, at a little over 2,800 kilometers thick. You might find it 2,900 kilometers thick, depending on which source you're looking at. That exact number is not going to be on the test. The mantle is divided into 3 mechanical layers, and we're going to talk about those 3 layers in just a little bit. The mantle also gets hotter the further down you go. So near the crust, the mantle is about 1,000 degrees Fahrenheit. Don't need that Fahrenheit again. And near the outer core, so at the bottom of the mantle, it's almost 7,000 degrees Fahrenheit. So again, the mantle is getting hotter the further down you go. The mantle is more dense than the crust, but it's less dense than the core. We just talked about the fact that the mantle is divided into 3 mechanical layers. From top to bottom, those mechanical layers starts with the lithosphere. Try that again. So the lithosphere contains compositionally the crust, but also the uppermost part of the mantle, but it's all very hard and rigid, so it's one mechanical layer. That's the lithosphere. Beneath the lithosphere is the asthenosphere. It's what we call plastic. So you see over here it says plastic. That doesn't mean it's made of plastic. It means that it's kind of gooey and soft, and it can even flow a little bit despite the fact that it is a solid. So the asthenosphere has convection currents in it as well that drive tectonic plate motion. You could say it causes tectonic plate motion. And then beneath the asthenosphere, we have the deep mantle, which is also called the mesosphere. It's just the deepest and thickest layer of the mantle. It's relatively boring compared to the lithosphere and asthenosphere. It's just kind of there providing the heat source for the convection currents in the asthenosphere. All right, going a little deeper into the lithosphere, which again is a mechanical classification. We're looking at how it reacts to stress. The lithosphere is made of the crust in the topmost layer of the mantle, and then most important, you could star this if you wanted to, the lithosphere is divided into tectonic plates. The surface of the Earth is not a single solid piece of rock. It's broken apart into lots of different huge chunks, the size of continents and oceans, and those are tectonic plates. The lithosphere is also very rigid. It doesn't act like a liquid in any way. Rigid means it doesn't bend at all. And it's also brittle. Brittle means it breaks under impact. It's about 100 kilometers or about 60 miles thick as a unit. So that is very, very small compared to other layers of the Earth. Going down, we have the asthenosphere next. This is another mechanical classification because we're looking at how it behaves. Most interestingly is that asthenosphere is plastic. It's not made of plastic, but it flows, it's soft, it bends. It is located beneath the lithosphere. It's about 180 to 600 kilometers thick. This is much, much thicker than the lithosphere, but you'll see it's much less thick than the mesosphere. The asthenosphere is plastic. Again, we've talked about this a couple of times. It is not made of plastic. It can bend without breaking, and it can flow despite the fact that it is a solid. I'm going to write that down so you don't miss it. It is a solid. It is a solid that can flow. It is possible. This ability to flow causes tectonic plates to move. And if you think back to our unit where we talked about convection currents, what's really happening in this asthenosphere is the heat from that deeper mantle is causing those circular currents to form in that asthenosphere, and it's causing the plates on top of them to move. I didn't draw this in the right location, but wherever those convection currents are forming, the plates on top will move. So it is the convection currents in the asthenosphere that are causing the tectonic plates of the lithosphere to move. Moving down to our last and deepest mechanical layer of the mantle, we have the mesosphere, also called the deep mantle. It's mechanical because even though it's still peridotite and still the same type of rock chemically or compositionally, it's back to being rigid. It's no longer soft and flowy like the asthenosphere is. The deep mantle is pretty boring. It's just hot and rigid peridotite. It is the deepest layer of the mantle. Deepest layer of the mantle. It is the thickest layer of the mantle. And it is the hottest layer of the mantle. It's very solid. Again, it does not flow like the asthenosphere does. Continuing down toward the center of the Earth, we leave the mantle and we reach the core. Again, mantle and core are compositional classifications. We're focusing here on a mechanical classification of the outer core. And the reason the outer core is a separate mechanical layer from the inner core is because the outer core is liquid. Both the outer core and inner core chemically are made of iron and nickel. Those are just two metals on the periodic table. They're mostly iron and nickel. It's about 2,200 kilometers thick, and it is hot enough in the outer core that the iron and nickel are liquid. The outer core is a liquid. It's about 7,900 degrees to 11,000 degrees Fahrenheit. And most importantly, with the outer core, these churning liquid metals create our magnetic field. They create the magnetic field that protects Earth from harmful radiation from the sun. And I'd really encourage you, I've linked a video underneath mine that better explains why the magnetic field is so important for Earth and especially life on Earth. And that magnetic field, again, comes from that molten liquid outer core. As those metals are churning around, the magnetic field is produced. And then finally, the last layer we will be looking at is the inner core. It's a mechanical classification. It's different from the outer core because this is a solid again. So this is the innermost layer of the Earth. It's about 1,200 kilometers thick. The inner core, like the outer core, is made of iron and nickel. And it's around 11,000 degrees Fahrenheit, but it is still a solid due to the immense pressure at the center of the Earth. It's under all of the weight of the entire rest of the Earth, and that is enough to make that iron and nickel a solid despite the incredibly high temperatures. That's it for new information, but on this last little bit, we're going to do a review. I'd encourage you to pause it and make sure that you can answer the question before I do. So let's take a look at that review. Again, hopefully you will pause it and see if you can answer the question before I write the answer in. That'll let you know how you're doing with this information on layers of the Earth. What layer of the Earth is thickest? Go ahead and pause it, see if you can answer. This, again, is saying the outer core and inner core are two different layers. That makes the thickest layer the mantle. What layer of the Earth is the least dense? If we were to look at that compositionally, it would be the crust. The lithosphere mechanically contains the crust. What layer of the mantle acts as a liquid despite being solid? This is the asthenosphere. And then finally, what layer of the Earth actually is a liquid? That is the outer core. All right, hopefully these notes were helpful to you and you got your note sheet filled out. As always, if you have any questions, make sure you ask. Thanks for watching.